Good day, everybody. Good morning, good afternoon, depending on where you are in the world. This is our next installment, current installment of our Tibco Analytics Meetup. We do this every couple of months, hosted and content provided by the Tibco Data Science team. Today, I'm going to kick off with an update on Spotfire 10, Tibco Data Science, talk a little bit about our new acquisition of Snappy Data and our new AI on Demand initiative. Then hand off to Peter, data scientist in the team, to talk about his new Voronoi tessellation geoanalytics Spotfire data function. I'm going to hand off then to Stephen Hillian on the data science team to talk about our new AI on demand solution starter covering digital twin, anomaly detection, wide data with a high-tech manufacturing context. And then wrap up with Helene Snelting on the data science team to talk about this new AI on demand initiative, along with our new community assets around anomaly detection, tips and tricks, and all of the goodies that are on the community site and the Tibco exchange. During the session, please submit your questions at any time via the Q&A option. We will answer these at the end or get back to you on those via email. And do encourage you to join the Tibco Analytics Meetup. This gives you the inside track on these Tibco Analytics Meetup sessions. You'll get updates, downloads to slides, notifications of the next meetup, things like that. So please join that. The group's now got more than 700 members. We've been at this not too long, so it's growing pretty rapidly. That's the best way to stay in touch. Okay, so an update on Tibco Analytics and data science. We're pretty excited to have launched Spotfire 10 at the end of last year. The two things that we're most excited about is this AI engine that we put inside of Spotfire that basically, when you point Spotfire at data, looks down at the data and finds the relationships in the data, in the actual data, and then suggest those to you based on your click behavior. So we click on a certain variable, Spotfire has automatically figured out what's related to that variable, and it will present those to you in the best practice visual displays in order of the strength of the relationship. So it just makes it very quick for somebody to get started and create an analytic application without knowing anything about the data. And also without knowing anything about how to use the software, because we've joined the AI engine to a natural language query interface. So you can ask Spotfire a question about what's in your data, what you want to look at, or ask a Spotfire question about how to actually use the software, how to style the color, the background, or style the analysis, or how to do a calculated column, or whatever else. So we've wrapped that all inside of this AI engine that allows people to very quickly build an application without having used Spotfire before and without having seen the data that they're looking at before. So that really broadens the audience for Spotfire and takes away a lot of the complexity. And then at the other end of the spectrum, we've deepened Spotfire by adding this real-time insight capability where we can join up Spotfire to an event stream, data coming in from Kafka or OSI Pi or whatever series of data you want to stream into Spotfire. And that allows the graphics to update as the new data arrive with full interactivity between any static visuals, any real-time visuals. That experience of combining best practices visual analytics with streaming data is very powerful. So just a quick example of this. This is a sped up hurricane from last season. You can see the hurricane coming up through the Caribbean, and as it lands there, we started to generate some insurance claims. This work was done with an insurance provider. You see the claims showing up on the right-hand side, the number of claims, the claim amount. We're also running from an inbuilt logistic regression model, figuring out which claims might be fraudulent. These little pink dots have been identified as potentially fraudulent claims based on the path of the hurricane, the size of the claim, in comparison to the value of the house, that sort of thing. And so basically keeping a real-time visual on what's happening on the map. You saw the map updating in real time. You saw the losses updating, the locations, the claim details that were identified to be anomalous, all of that. So you can imagine how to apply this to your scenario of updating data. And the data doesn't have to be sub-second, you can speed it up like we did, or you can apply it to data that's updating on some other frequency. So that's, in a nutshell, Spotfire 10, this new AI recommendations engine in Spotfire 10, the new live data streams. We're also super excited about what we've been doing on the data science side of the house with our web-based, collaborative, interactive data science application that drives calculations down into the database for either doing data prep or machine learning, that connects people into project teams, connects in the corporate data assets into that team, and provides this web-based experience, collaborative experience for doing modern data science. And then, these products can both access the same data source. They can access Tibco data sources, either on-premise here on the right or in the cloud here on the left, and provide this combined data science plus visual analytics capability, in operations. And what we've added into this recently, a couple of weeks ago, we acquired the company Snappy Data. And this technology is relevant to both our Spotfire on the right, our data science on the left, and it provides a Spark acceleration. So Spark environment, which is very common and widely used in data science, as you guys know, fusing that with this capability to accelerate the calculations. So you can come in through Spark, but you can arrange your data in our high-volume, multi-parallel database, either as a columnar, a store, or row store, and this provides you this low-latency, accelerated Spark experience. It includes this approximate query processing. So if you've got billions of rows and you want to make it even faster for interactive visualization, it's really a combination of transaction processing and analytics and streaming, for getting to big data in low-latency situations. So you can ingest streams into the engine. You can use these approximate queries to get a faster response time when you've got billions and billions of rows. You can access through the Spark APIs to access this engine. And inside the engine, it's super fast aggregations. It has this multi-version concurrency control, so you can be writing as well as reading at the same time, and it takes care of that. You can connect up modern data sources as external virtual tables and basically design this analysis to take care of both interactive viz and data science across this analytics data fabric. We're rebranding Snappy as Tibco Compute DB, and you'll see this come out as a data source for Spotfire and Tibco data science in the coming weeks, coming months. Now, the analysts like what we've been up to. And they're a tough group to get credit from, but you see we jumped into the leaders quadrant on the data science, just came out this year. Also just out the critical capabilities that goes on along with the magic quadrant, probably even more important. It evaluates the product. We were number 1 on 3 of the 4 critical capabilities and number 2 on the 4th one in data science. And then on Spotfire, we are a hair away from the magic quadrant. And you'll see the critical capabilities come out on that here pretty soon. I can't announce those today, unfortunately, but we did very, very well on those, even better than we did on the MQ position. And while we're jumping up, our competitors are going in the opposite direction, which is really good news for us. So if you want to justify, your use of our software to your management, this is a good time to do that, and these are some good graphics to use to do that. Okay, so on today's presentation, we're going to cover a couple of these areas where AI has been very successful, manufacturing and energy in particular. And we've been working on this series of solution starters called AI on Demand. You'll be hearing from Stephen today on our digital twin anomaly detection for manufacturing, and from Peter has a component he'll be showing that's very relevant in the energy production surveillance area. But these are the 5 solution starters that we're working on. These include, you can look at these on the community site. Helene will show you a variety of assets that you can download, templates, data functions, things like that. All kinds of things that you can use to get started in these areas. And we chose them to be broadly applicable across a variety of industries. In the energy sector, we work a lot in the upstream, exploration, production, and in the midstream, down into downstream, refining, supply, manufacturing. And Peter's demonstration today fits in with that. We did an energy event in Houston in February. We had IHS give a demo of Spotfire 10. We had Oxy and Hunt Oil present. And then in our presentation, we quickly built a dashboard in Spotfire in like 60 seconds on some production data. Peter did some geoanalytics there to line up the geology with the well locations. He's going to show that today. We did some data virtualization and streaming, and then we showed how that can all be tied together with our master data management new product, EBX. And then on the high-tech manufacturing side, bringing together edge data from tooling inside of a production facility, doing a fault detection, run-to-run control, yield optimization, well, those things on the event stream, informing that through data science, which Stephen will show you today, and how that feeds on out into Spotfire for yield optimization and visual analytics. And this helps you do real-time notification to your system to either stop the equipment, maintain the equipment, send somebody an email when something gets out of control, do a product hold. All of those things you can do inside of this set of assets. And we've been doing a lot in the high-tech manufacturing area. We're used by most of the top 20 semiconductors companies. We participate in high-tech manufacturing industry groups, including a proactive yield management work stream. We've got a number of presentations coming up at the big conferences, Semicon, ASMC, and our AI on demand piece that Stephen's going to show. We're going to do a deeper dive of that coming up here pretty soon on Data Science Central. So thanks for that, keeping track of that. You can certainly follow me on Twitter. I try to promote the team's work that you'll see some examples of today, and you'll see updates on my Twitter feed if you want to come there. I'm going to hand off at this point to Peter for the first part of today's demonstration on his new Voronoi tessellation Spotfire data function. Peter?
Hi, in this video, I'll be introducing the Voronoi Polygon data function for Tibco Spotfire. The idea behind Voronoi polygons is that if you consider a few points in XY space, the space can be partitioned into polygons that show which of the points is the nearest. For example, for any location within this red area, the closest of the 4 points is this lower one. This process can be continued with any number of points, each generating a surrounding polygon. To show a real example, I have a series of point locations on a map. Each location has a measured one-day precipitation value, which is used to color code the points. There are some patterns, but the variation and outliers in the data make these hard to see. I lasso a bunch of these points to mark them. This kicks off the Voronoi polygon calculation using the data function I'll be walking through in a moment. You'll see here an individual polygon drawn for each point I marked. These polygons are nice, but they have not reduced the variability in the data. I'd like to aggregate these data points so each polygon represents a few points. One of the input parameters lets you control the aggregation, so here the individual variability is a bit less crazy and you can begin to see the broader pattern. Using these same aggregation settings, if I mark a larger region, I can see a strong band of precipitation. This data function is available on the Exchange with the Spotfire tag. If you go to the page for this component, you'll see a brief overview, a place to download the most recent release, also a link to a version on the cloud you can see right away to see some of the capabilities in action. The cloud version shows one use case where the Voronoi polygons are used as a framework for displaying data. As a filter is applied to the underlying data, the visualization changes. Here we're stepping through time. You can see a pattern changed through space and time. The data shown here is from the storm in March of 2019, known as the bomb cyclone. You can see the bands of precipitation moving across the country. The Exchange page also contains a user's guide to the data function that explains all the input parameters and outputs, as well as a link to our main page on Tibco Spotfire location analytics. So let's see how this works. Here I've got some precipitation data. These are measurements from a single 24-hour period from a number of ground stations. This data is a snapshot of precipitation during the March 2019 storm. The data are from NOAA's website from a large network of ground stations. The coverage extends worldwide. I'll display this data in a Spotfire map chart. All I have to do is bring in a map chart and Spotfire automatically recognizes latitude and longitude. It's also automatically chosen the variable elevation to size the symbols by. I'll switch both the color and size to vary with the precipitation level. We can see there are some strong bands of precipitation that occurred. I'd like to get a sense of the broad patterns of precipitation and average out some of the variability. To do this, I'll use the Voronoi data function. We have several data functions that do a very similar process of generalizing point data to show an overall spatial pattern in an area. Besides Voronoi, there's the heat map data function, as well as the contouring and the hex bin data functions. Each of these has slightly different characteristics. The Voronoi data function lets you create a display as I'm showing in this video, plus it lets you overlay aggregated values across point data, and it supports the live filtering as we saw in the cloud version. Here's the process to use the data function from the Exchange. Once you download and unzip the file from the Exchange, you'll see several examples and help files, as well as the main asset, the file which ends in .sfd. This version will update as ongoing changes are made. To use a copy in Spotfire, I'll browse to the data function menu, click on Import, and locate the .sfd file. This brings up the data function. Use this Run button to insert the data function into the Spotfire file. This brings up the Input-Output dialog box. All the inputs are shown here along with a brief description. Only the first two inputs are required, the rest can be left blank. These first two get connected to the latitude and longitude columns in the data. It's usually valuable to aggregate several points together per polygon. This reduction factor specifies the average number of points grouped per polygon. We can generate just polygons here, but here's an optional input where we can also specify numeric columns to aggregate. For the output here, we'll only be using the first object, which will become a data table called Voronoi. We'll add the results of our calculation to our visualization. One easy way to do this is simply to open the data panel and find the new table. The Voronoi table has a geometry column that contains the tiles. We can simply drag this column onto the map into the target area that appears. We'll set the polygons to be colored by our aggregated values of precipitation. We can turn off the source points to see the overall pattern in the polygons. We can also change the appearance, for example, the transparency. By default, the outer boundary of the polygon region is the convex hull of the starting points. One option is to provide a bounding polygon to use instead. Here, I've got a simple table of latitudes and longitudes that define the continental US outline. Going back to the inputs of the data function, I can connect these columns to the appropriate locations and rerun the data function. The results will be trimmed to the outline. Here I've illustrated how to use the data function to create a Spotfire visualization that generalizes point locations, so that an entire region is covered with polygons. Two common use cases are covered step by step in the user's guide. The first use case addresses the situation where you have two types of locations. In one group of locations, such as wells, you would like to estimate some geological information, such as porosity. Geological information is available in the area, but at different actual locations. Here we create Voronoi polygons for the geology data. The aggregated geology values in the Voronoi polygons are then overlaid onto the well locations, so these now have estimates for the geology parameters. In the second use case, we'd like to visualize data that varies both in time and space, for example, this storm data. The best way to go about this is to use Spotfire's native filtering capability for the time variations and to leverage the polygons as a visualization framework. This is accomplished by appending a polygon index to the starting data and using this to link the data tables. This is also detailed in the user's guide.
Just to remind everybody, that's all on the Exchange. So go to the Tibco Exchange, or you can go to the wiki and find a general set of instructions for location stuff. So on a couple minutes over, so pass on to either Stephen or Michael. Where's next? Stephen, I guess.
We'll go straight to Stephen, I think. Yep.
Yep. Thanks, Peter. That's pretty impressive. So, complete change of topic now. I'm going to talk about an example from the world of manufacturing, creating digital twin models. So this is going to be a brief demo of actually a pretty major project that we've been working on in the last couple of months, analyzing sensor data from manufacturing processes in order to understand and ultimately increase product output, increase product yield. Now, in this case, it's the yield for semiconductor wafers used to make chips, integrated circuits. But those same methods that I'm showing you today can actually apply in other settings too. So genomics, for example, genomic sequencing. By contrast, digital advertising, where you want to track many different URLs that customers visit in order to draw conclusions about their profile. So anything where you've got sort of an outcome that you're interested in that may be driven by a haystack of variables, and you kind of want to find the needle in the haystack. So in this case, with the digital twin for the manufacturing plant, we're creating this twin as a virtual representation, well, a model, really, a mathematical model of the manufacturing process. And this is enabled really by the convergence of a lot of recent technological advances, IoT, all the sensors that are scattered throughout the fab, machine learning in order to build the predictive models, and perhaps above all, big data technology, which is really necessary to handle what comes down to literally millions of variables. So this diagram represents a process flow, sort of proceeding clockwise here. And at each process step, as the wafer goes through the manufacturing process, there's sensor trace data. And these might be, say, pressure or temperature readings or the thickness of an etching, whatever it might be. And there may be literally thousands of these process steps, you know, as these chips get more complex. And within each process step or within each sensor, there may be thousands of time series measurements. So thousands of sensors, thousands of time series measurements, each of them interesting, right? Which point of which sensor is likely to be indicative of poor yield or good yield. That's really at the heart of what we're trying to do here. Now, once processing is complete, we've gone through all these processing steps, the product is tested and ultimately producing a count of failures, or if you view it the other way, a measure of yield. So with that, we can create a model of yield loss. And that's a model that's a function of all these process parameters, basically the sensor readings, to produce the measure of yield. So think of this as just your standard sort of regression model, right? Where you're trying to measure an outcome variable, in this case yield, and the inputs are these these process parameters, that basically the sensor readings from each sensor and each point in time. So that's the digital twin model that I'm going to create. And this is not any ordinary model, because again, there can be thousands of steps with thousands of sensors, each having these thousands of time series points. So that's millions of individual input variables, and then thousands, if not more, of observations, meaning, you know, the number of wafers going through the factory. So you're aggressing thousands, if not more, of observations against millions of variables. So not a big surprise, big data technology is going to be needed. So how do we solve this? Well, we do it with two major components of Tibco's analytics stack. Starting over here on the right, there's sort of the end product, if you like, is Tibco Spotfire, where we visualize the results of the model. So nice and easy to understand for the fab manager in terms of like yield charts and simple heat maps showing the causes and effects, all happening within Tibco Spotfire. And that's backed by large-scale processing by the Tibco data science platform over here on the left. And that's where we do the analytics. First, really in two chunks here, our big data capabilities, where we're leveraging Spark and in-cluster processing to do the data processing, and then Statistica to rapidly build predictive models. Okay, cool. So let's actually see this in action now. I'm going to switch over to, again, I'm going to start sort of on the right of that diagram with the final output, right? This is the final result, the dashboard that's created in Spotfire for the factory manager. Initially, there's only a low level of yield loss over here on this top chart here, where I'm looking at the failure percent, if you like. Now, the heat map downstairs here shows the results of the digital twin model. Each row here represents one of the sensors, and the columns represent a time series of, you know, those sensor readings, pressure, temperature, whatever it is. And cells are colored by variable importance. So the heat map is showing which sensors and which points in time we should examine in order to understand what is driving yield loss. That's really the core of this. And right now, as you can see, not much of interest is happening. No variables are particularly important, because nothing important is happening. So let's go ahead and get the latest data off the factory floor. And you see here some spikes in yield loss. And in turn, we've rerun the model. So we're rerunning this big data digital twin yield model, and we're populating the heat map with the results. And if I go back in time now and sort of compare that, you can see here, again, things were normal, now we're getting some spikes. So if I go ahead and mark some of these bad lots over here, and I also pick this top sensor, which is where it seems like the most important variables are happening, the most important sensor and time points. That allows us to actually drill into the actual sensor traces. So red here means bad lots and green means good lots. And we're seeing the good stuff has these elevated, say, pressure readings, while the bad material is just kind of flat there. So it's showing us why these have been highlighted. There's a significant difference between good and bad here. And so that's why sensor 4 and over this particular time period might be interested in looking into. If we go back to the earlier time period where things were less interesting, you notice those two things don't differ anymore. So you can see why that's been selected as a sensor of interest, because when yield is bad, interesting things happen. When yield is not bad, interesting things don't happen. So it's a good sensor to look at. So this is really significant, right? Because what this means is that we're able to go directly from looking at product yield loss, just raw sort of aggregate data, to really dig in using the models to figure out which are the most important sensor readings of all of those thousands of sensors and millions of inputs. And so that's going to provide an important clue to understanding the cause of the yield loss. So how do we do that? How do we create those measures of importance? Well, that's a hard problem. That's a hard question to answer, and I'm not going to try and do that just in the next 7 minutes. But let me see if I can give a sketch of the sort of thing that we're doing. And what's remarkable to me here is using the Tibco data science platform, which is what you're looking at now, a web-based platform for doing complex machine learning, is we've created a big data workflow that computes variable importance for these millions of variables based on all these observations, thousands of observations. And we're able to do it with a simple visual workflow that leverages the full computing power of a Spark cluster. So I think that's pretty cool. Now, the workflow is composed basically of 3 main steps. The first one up here is where we take the original time series. Let me open this up to show you the time series. That's the original input. So for each wafer and for each sensor here, we're showing the time series. So here's the time series. You can see it's pretty wide. In fact, you know, almost 1,000 columns, so almost 1,000 length in time series. And the first thing we're going to do is to reduce the size and complexity, because there's just too many points and we don't need all of the detail of the time series. So we're going to reduce that complexity using a method called Sachs Encoding. And again, I'm not going to go into the details of this, but you can see visually here what that does. Here's the input. Here's a single time series just for illustration that I've just picked out of all those thousands of sensors. And after it's gone through Sachs Encoding, you see, essentially we haven't lost any information. It's still going up. We're still getting the same spikes, but there's just a lot less data. Instead of 1,000 sensor readings, we're now just taking about 50. So the output of the Sachs encoder, once we've cleansed it up a little bit, is really a list of these variables, each sensor and each time point, and the actual value at that point. But instead of 1,000 of them, you see that there's actually, just scrolling down, about 50. And then we switch to another sensor with different time points. You'll also notice another thing. The output of the Sachs encoding has now kind of pivoted the data set. We're now no longer having like 1,000 or 50 points across. We're getting 50 rows down. And the nice thing about that is that it's sort of a way of simplifying the data, because imagine trying to do analytics on a table with 1,000 or 1,000,000 variables. We can actually now take the 1,000 sensors and 50 points. So that's 50,000 variables now. So a little simpler, thanks to the Sachs encoding, but still a lot. We don't want to store that in tabular form. We've got it in the stack form, and we can now pass this to the real variable reduction set, that trims down these thousands of variables into something much smaller. So basically this wide data variable selector computes correlations between the outcome of the manufacturing process, so the failure that we've included here, and these thousands of input variables in the form of the time series data. And here's the output of the wide data variable selector. It says for each of these variables, remember a variable is a point in time for a given sensor, we've got a correlation. How significant is that, just purely in terms of its individual correlation with the yield output? And what that allows us to do now, here's where now things become very simple. We can now just look at those correlations, draw a quick histogram. We can look at all the boring ones here in the middle. Those are the ones with correlations centered around 0 here. So we can ignore all those, filter those out. And now we just come out with a smaller number of variables, and now we can unstack back, pivot it back. And now we've kind of got our original data set back, but now with far fewer variables, just the important ones. And now we're in happy land for data scientists, right? A manageable table of variables, of the most important variables. And now we can use any technique we like. So having computed the correlations and filtered them down, we can feed it into, in this case, we're computing a random forest regression. And the nice thing about that is that it can do nonlinear effects, it can do interactions between variables, and we get also measures of variable importance. And in fact, you see here at the top and then further down, here are the points from sensor 4 that we were actually seeing in our heat map that were now yielding in a visual format back to the fab manager so they can see what they need to go in and investigate. So what I love about this, you've got beautifully simple charts that are exactly what the factory floor manager wants to be able to see, but backed by really powerful analytics using Spark and Hadoop and sophisticated algorithms that we can feed into our Spotfire dashboard. Just to finish up, I want to mention some performance numbers, because in the end, right, you want to have, if not a live view, a pretty fresh view of the data, because these yield numbers can change sort of pretty quickly, and you want to drill into them pretty rapidly. And even the models need to change fairly rapidly, because what on one day or in 1 hour might be the most significant sensor may not be true shortly afterwards as conditions within the factory change. So we've done some performance benchmarks, and it's on a relatively typical data set where you have, say, maybe 1,000 wafers going through and maybe 20,000 sensors, which, once we've done the Sachs encoding, that's essentially 1 million variables because there's 50 time points per sensor. We can do this processing in about a minute. If you go to something much more extreme, this is really the challenge that was given to us by one of our customers. You're now talking about many more wafers, hundreds of thousands of wafers, millions of variables, terabytes of data. We can still chomp through that pretty rapidly. Within 15 minutes, we're going to be giving an updated model back to the people that matter. So I'd like to thank the whole data science team that you see mentioned on the bottom of the slide here. Lots of work gone into this in terms of creating simple and intuitive visualizations, but backed by powerful and scalable computations. Everything I just showed you is computed in Spark, is fully parallelized, every single one of those algorithms, from the row filters up to the wide data variable selection. And this is available within the Tibco data science platform. And as I say, I think it applies to really any situation where you have a lot of different, well, when you're trying to find the needle in the haystack. Okay, I'm going to stop sharing now and head back to Elaine, who's going to give us an overview of what's been happening in the Tibco community.
Wonderful. Thank you, Stephen. That was really amazing, what you just showed. So, yes, the Tibco...
One thing, by the way, before I finish, Elaine, I did want to mention, obviously I kind of rushed through that. There's a lot of complexity. We're having, as I think Michael mentioned, a deeper dive into this as part of Data Science Central is hosting Tibco next Tuesday at 9 a.m. So April 30th at 9 a.m. Pacific time. So you can see a lengthier, more detailed version of this.
Perfect. We'll be sharing the link to that registration in the meetup that Michael showed earlier, so that everyone has it. Or maybe you can add it to the chat while I'm presenting, Stephen. So yes, this part of the Tibco Analytics meetup is always to point you to all the assets that we're sharing on the Tibco community, because the ultimate goal of this meetup series is to inform you and to enable you with tips and tricks as users, specifically in a bit more advanced areas, as you've seen in the previous demos. So we obviously don't want to just leave you with just this webinar. We also want to point you to all the resources where you can learn more and find out about the details. For those of you that are new to the Tibco community, this is the first screen that you'll see when you join the Tibco community. If you've been a user for a long time, you'll notice that the UI has changed a bit. So this is to help you find things easier. You can now select the products that you're interested in to make sure that the content that's being shared to you is a bit more specific. Search is very prominent. We try to use tags a lot as well to help you find things more easily. So hopefully you'll enjoy this user interface. We're doing a poll, I think, soon as well, so you might get asked to provide a bit of feedback on how this is working for you. But the Tibco community has a lot of aspects to it. You can find out product information. There's our answer section where you can ask questions and get answers from the full Tibco community, including all of you. There's the exchange that hosts the templates and the data functions, the downloadable software extensions that Peter, for example, just showed. And there's the wiki where we summarize all of the tips and tricks and provide all the information supporting the items that we put on the exchange or new product features. And finally, there's also ideas where you can make suggestions to our product management team and have direct interaction with our product management team on things that you'd like to see added to our products for next releases. And you can also download trials from the community. So this is really a user forum, user community, and we hope you take full advantage of it. So Michael talked about the AI on Demand series. Stephen showed a demo showing one of the demos and the assets that was created for it. So this is the link to that site, and you'll be able to sort of follow along over the next months in terms of the content and the white papers and the demos and videos, and also the live meetups that we're hosting in the various regions around the world to support you on learning what we're sharing with you. And in addition to that, we've got our Tibco Now user conference, which are the big events that Tibco organizes. One year it's in the US, and the other year we do it in the different regions. So the Singapore one has just been completed. It was a very successful event, fully sold out, and we're now gearing up for Chicago and London. So hopefully you have all the information. If not, go to now.tibco.com or talk with us about it. And we're going to give deep dive workshops on the type of demos that Stephen and Peter just showed you. So you'll be able to learn more hands-on, meet with our team and Michael. So looking forward to seeing you there. This is the slides, and just for everyone, you will get all of these slides as a reference. So that's why we have this final section here, just to make sure that you can follow up with all the links of the things that we presented to you. So this is a link to the specific template on the community exchange, but also a link to the Energy Day in Houston that Michael and Peter refer to, with the presentations given at that event for you for reference. And then I wanted to remind you and actually point you to an expanded amount of resources also on the Tibco community, which is called the Spotfire Customer Orientation section. And it's really for new users of Spotfire to get started on how to set up the products, where to get the products, how to sort of have some first training and understand how to use the product, specifically Spotfire. And then it links to all kinds of useful other content on the Tibco community to help you get started, but also to sort of refresh your skills and to expand your skills once you're set up. So this is built by the customer success team in response to the frequently asked questions that we get from all of you. So hopefully you'll find this really useful. It's all free content and has lots of videos and quick starts to get you started. So the link is on this slide as well. And one component of that enablement that we provide is the Dr. Spotfire session. It's a monthly event that's being hosted by our customer success team in conjunction with our technical consultants and data science team. And we do it, it's a 30-minute webinar. And we cover one specific topic, again, in response to the questions that we get from the community. And this particular session is indexed really carefully so that you can search later on as a reference on the Tibco community and see these videos and sections of the Dr. Spotfire sessions to teach you tips and tricks on how to use the product. So just a reminder of this very useful webinar series to take part in as well, or to point your colleagues to. I also included a number of links to Spotfire 10. So Michael talked about the key features of Spotfire 10, and I think most of you are upgrading or have upgraded to Spotfire 10 already and may benefit from seeing a few more videos and learning a bit more about all the features and how to use them. So hopefully you'll enjoy these examples and detailed descriptions on how to use the product. And again, as I showed earlier with the answer section, you can ask questions if you want to find out more information, and just link to the specific pages and we'll help you out. And then a very special announcement today. Andrew Berridge, part of our Tibco data science team and you know, a presenter in these sessions as well, is about to launch a new Spotfire book. It's a second edition of the Tibco Spotfire comprehensive primer that was released a few years ago and is now fully updated to Spotfire 10. We're very excited about this. It's going to be available in a few days, either from Pact, who has published it, or from Amazon. You can pre-order. You can find lots of information in there. It's a thick book that covers all aspects of Spotfire 10 with a lot of examples and very closely associated with the Tibco community. So, you know, you'll find examples in the book that have downloadable sample sets on the Tibco community. And you know, if any updates occur, we'll provide those in the community as well. So there's a link to the Tibco community page, which has a description of the book, and we'll be communicating lots more on this to help you with your Spotfire journey as well. And then almost finally, this one is the Analytics Bulletin. This is an initiative from Tibco Marketing, just to sort of help you keep up with all the various information that you can get from Tibco in terms of learning, webinars, assets that are available, white papers for you. So this is a summary email. If you're registered for this webinar, you'll probably get this automatically. If you don't have it yet, we're going to post this on the community as well, so you can just find it there. If you have specific interest, just let us know, but hopefully you'll have easy access to this summary with just links to remind you of everything that's available to you. We'll share this slide with Tibco community links to bookmark. We update these every time sort of in line with where the latest and greatest information is for you. So feel free to use that as well. And actually that brings us to the final slide, which is Q&A. So hopefully you'll find all these links useful. And we now have another few minutes left to answer some questions from the audience. So I think...
Excellent. I think, Stephen, you're going to run the Q&A, right?
Yeah, that's right. So if you've got any questions, you can direct message me or publicly enter something into the chat window. I got one already, actually for Elaine, just while you're chatting. So if people are wandering around on the community tips and tricks page, the question is how you get help, support. So I guess the question is, you know, if there's some technical questions you have here, or you want to get hands-on assets, you don't know how to find them, what's the best way to get sort of live, in quote, support?
Yeah, so I'm not sure if we can do direct live support, but a quick support, absolutely. Our team is on the Tibco community all the time. We monitor the questions, and support team from Tibco monitors the questions as well. So typically you get an answer within 24 hours if you post something on the community. Depending on the quality of your question, you know, you get a quicker answer. Sometimes we ask for a little bit more input to be able to answer your question, or we may point you to a Dr. Spotfire session to answer. But use the answer section to post your question, and always include the link of the page that you are referring to. So rather than posting a comment on the page itself, please use the answers section on the Tibco community, because then everyone can benefit from answering, and also the question gets exposed to everyone monitoring the questions. And maybe finally, if it's very data science specific, what will also speed up getting a question answered by our team is by tagging it with a hashtag data science, because we have a specific sort of pop-up for our team where we can distribute these questions across the team. And it's not our formal support. You can also go to formal support, obviously, when there's a production issue. But if it's just a question about how to do something, then the Tibco community is the right place to ask questions.
Great. Here's a question that's come up. Peter, this is for you. So you were using the Polygon script, the Voronoi Polygon script. Do you have to customize the actual script first to work with my data set, is the question.
Shouldn't have to. If your data set is latitude, longitude, it'll handle it. All it basically needs is point locations, and it can be latitude, longitude, or if you just have general X and Y, there's a Boolean switch to set there. So no, you should be able to just immediately take your data set and use it to make your shapefile.
Cool. Somebody asks, can you talk in more detail about how a Voronoi polygon relates to the distance between points and how the number of clusters and the reduction factor are used?
Sure. Well, right. And actually, it's a good observation is that the regions where there are higher density of points have the smaller polygons. So it's essentially k-means. It's the same thing that k-means clustering is doing. Is it's kind of a natural way of recognizing that some areas are higher sampled than others. So it does essentially look at the spatial statistics. And I forget the other part of the question about the Steve, what's the last part of the question? Sorry.
Yes, how the number of clusters and the reduction factor.
Right. So if you specify, so it needs to know, it basically uses k-means clustering, and k-means needs to know the number of clusters. So if you choose to use the reduction factor, which I find convenient, it simply takes the number of points and divides that by the reduction factor and rounds it up. So that's the number it uses. So it's a pretty simple-minded thing, but if you do want to specify an exact number, like for example, if you have a map of the US and want to use like 50 regions or 48 regions for the lower 48, you can specify an exact number of clusters to use.
Okay, great, thanks. Here's one for me. Did you have to write custom code for any of the wide data workflow? That's an interesting question. Yes and no. So as a user of the system, so in particular the first organization that's using this particular workflow, no custom code for them. It's just, you know, drag a few operators onto that visual editor, and Bob's your uncle. You're off starting to do your wide data analysis. Now, having said that, we realized early on that the time series were just way too big for any algorithm to be able to sort of sensibly handle. And Dr. Tom Hill, who works here at Tibco, made the suggestion of using Sachs encoding, which is a really powerful method. Well, we didn't have that in the product, in that visual drag drop environment. Now, you can always write sort of custom Python code and just inject that Python or R code and just inject that into your visual workflow. It's complete interoperability between the code and the visual. But what we actually did is we encoded the Sachs encoder, if you'll excuse the English, and wrap that up in a special SDK, which makes it available as a visual operator. So within a couple of days, we were able to deliver to the data science team a new function. So we've made the platform completely extensible in that sense that you can add new algorithms. And when I say you, that means our data science team, our professional services team can add new algorithms, our customers, anybody who is working in or around the data science platform can add new visual operators. One sort of administrative question, will the slide deck be available? And Elaine, I think you said, yeah, that's going to be sent out so that people have access to the links and so on, correct?
Right, yeah. And I think we'll have to wrap up, Stephen, if you allow me. Yeah, so if there are any remaining questions, we'll get in touch via email. So thanks everyone for attending. We will share the deck and the slides both through the Meetup as well as through the community, and videos will be posted on YouTube. So you'll have every opportunity to look back and learn what we shared today. So we'll be holding another one, another Tibco Virtual Analytics Meetup probably in 2 to 3 months. So we'll be announcing that again through the Meetup and through that newsletter that I showed you. So hopefully we won't miss contacting you about that. So hopefully you enjoyed it. The contact details are here. Get in touch if you have any specific topics you'd like to see in the next version. And we thank you all for attending. And thanks Stephen and Peter and Michael for your presentations.